Okay, let's get started. We'll finish up. We should be here, number 11. This one gives us an interval, right? So it tells us we're going to solve over the interval of 0 to 2 pi. Another thing to keep in mind is that this one you could have extraneous solutions, all right? And I'll explain what that means and why that would happen in a second. If you remember what we did yesterday, we would try to get our trig function by itself. But what do you notice here? Why is that more difficult here? Yeah, there's a cosine and a sine. They're two completely different trig functions. Okay, so you might be kind of stuck, right? There's no way to get, the way it's written, a cosine and a sine to be the same thing. Is there anything we can do to maybe make it so that we could get it to be the same thing? Any ideas? All right, in what instance, let's say, that we've done before, could a cosine turn into a sine, or a sine turn into a cosine? If, what happened? What'd you say? All right, so good, right? We want to square both sides, so I'm going to square this side, and I'm going to square this side. What does that do, right? Let's see what that does. The left-hand side, cosine x plus 1 squared, if you write it twice, you FOIL it, this is going to get you cosine squared x, thanks. Cosine squared x plus 2 cosine x plus 1. And then the other side just becomes a sine squared x. All right, but again, you guys can have a look at your Pythagorean identities. What does sine squared x equal? Other way around, 1 minus cosine squared x, right? So let's go ahead and replace this with a 1 minus cosine squared x. All right, and then the other side is exactly the same. All right, so I have a cosine squared x plus 2 cosine of x plus 1. All right, and then now what does it look like we can do? Yeah, right, so let's get everything to one side. Let's set it equal to 0. So I'm going to subtract 1 on both sides, and let's add cosine squared x on both sides. All right, so then everything over here is going to cancel out, and then on this side, cosine squared plus cosine squared is going to get you 2 cosine squared x. All right, then we have a plus 2 cosine of x equals 0. All right, what does it look like we can do now? Yeah, take out a common factor. All right, what is it in this case? Yes, right, 2 cosines x. And then you're left with just a cosine of x plus 1 equals 0. All right, and then think about what we did yesterday. What can we do now? Yeah, nice. Nice, guys. So I have 2 cosine of x equals 0. And then we have, on the other one, cosine of x plus 1 equals 0. All right, over here, all we have to do is divide both sides by 2. We get cosine of x equals 0. And then the other one, we can subtract 1 on both sides, and we get cosine of x equals negative 1. All right. Now we check our unit circle, right? These aren't our final solutions, but what we do now is we check our unit circle. We see what values of x, when we plug it into cosine, get us 0 and negative 1. All right, let's start with 0. What values of x get you 0? Okay. Pi over 2. Anything else? Good, right? So x equals pi over 2. X equals 3 pi over 2. All right, we were given an interval of 0 to 2 pi, so I'm not going to add the 2n pi to this one. These are just our two answers. All right, what about cosine of x equals negative 1? Good, pi, right? Good, right? So these, in any normal example, would be our final answers. All right, but what do we have to check for? Yeah, good. So we're going to check for extraneous solutions, right? This is a scenario where you could get them just because you had to square both sides, right? If you remember way back, like let's say I gave you the square root of x equals -3. Okay, you might square both sides and you get x equals 9, but when you plug it back in, you get positive equals a negative, and that doesn't work, right? Similar case here. If you're squaring both sides, you could be including a negative answer where there isn't one. All right, so let's check those answers on the side. All right, so let me check those. We're going to check, let's go one by one. Let's try x equals pi over 2. All right, so now go on your unit circle. All right, at pi over 2, what is the ordered pair that we see there? Okay, 0, 1, right? And then keep in mind the 0 is the x, the 1 is the y. And remember that the 0 represents the cosine. Remember that this is always cosine, sine. Our original equation was, what was it? Cosine x plus 1 equals sine of x. So I want to plug those numbers into cosine of x plus 1 equals sine of x. I'm not going to use the x and the y, though. I'm just going to keep in mind that cosine is 0, sine is 1, right? So let's plug these numbers in, right? If cosine is 0, it's going to be a 0 plus 1 equals 1. Are you okay with what I plugged in there? All right, okay, good, all right. So I get 0 plus 1 equals 1, and then we get 1 equals 1. Is that a true statement? Yes, it is, right? So x equals 0 is a valid solution. I'm sorry, x equals pi over 2 is a valid solution. All right, let's do the same thing with 3 pi over 2. What's the ordered pair that we see at 3 pi over 2? Good. And then keep in mind, 0 is the cosine, and -1 is the sine. So let's plug those numbers into this equation as well. Cosine is 0, plus 1 equals sine is -1. We get 1 is -1. Is that a true statement? No, so then we're going to cross this one out. That one's not a solution. All right, and let's do the exact same thing at x equals pi. All right, what happens at pi? What's our ordered pair there? Nice, -1, 0, and then keep in mind that it is cosine, sine. So let's plug those numbers in. We get -1 plus 1 equals 0. What's -1 plus 1? 0, so we get 0 equals 0. Is that true? Good, right? So what are our only two solutions here? Pi and pi over 2, right? 3 pi over 2 is extraneous. So again, we squared in the beginning. That square wasn't there originally, so we do need to account for the extraneous solutions. Okay, so let's keep going. Let's try the exact same thing with the next one. All right, so help me out with this one. What's the first thing we should do? Nice, square both sides. So I'm going to square and square. And then when we do that, keep in mind sine x plus 1 squared is going to get you sine squared x plus 2 sine of x plus 1. And then on the other side, we have a cosine squared x. All right, and then what can we do to get the exact same trig function? Yes, nice. So then this is going to become sine squared x plus 2 sine of x plus 1 equals, using our Pythagorean identities, this is 1 minus sine squared x. And then just like before, we can get everything to one side, set it equal to 0. So let's subtract 1 and add sine squared x. And then when we do that, we get 2 sine squared x plus 2 sine of x, and then 1 minus 1 cancels out. All right, so then we're left with this equation. Nice, good. So then we can get 2 sine of x. And then on the inside, we're left with a sine of x plus 1 equals 0. When you set both of these equal to 0, we end up with sine of x equals 0 and sine of x equals -1. All right, and then check your unit circle. All right, what values of x when we plug into sine get you 0? Okay, pi and 0. All right, so we get x equals pi and x equals 0. So again, we are in the interval of 0 to 2 pi. All right, and then what about sine of x equals -1? Where does sine equal -1? Yes, so we're going to do x equals 3 pi over 2. Okay, good. So we got 3 answers. What should we do now with those answers? Check them. Nice, right? So I'm going to do it on the side. Let's check them. Let's first check, doesn't really matter which one. Let's check pi. Right, what's the ordered pair that we see on pi at our unit circle? Good, -1 comma 0. What's -1? Is that cosine or sine? Cosine. And then 0 would be the sine. Right, so let's use -1 as cosine, 0 as sine. Let's plug it into the original. The original that we're plugging into is sine of x plus 1 equals cosine. All right, so then I'm going to have a 0 plus 1 equals -1. Is that true? No. So then pi is not a solution. Let's try the exact same thing with 0. What's the ordered pair that we see at 0? Nice, 1 comma 0. And then 1 is the cosine, 0 is the sine. So then we're going to have 0 plus 1 equals 1. Is that true? Yes, it is, right? So 0 is a solution. Let's do the exact same thing at 3 pi over 2. What's the ordered pair that we see there? Nice. And then 0 is the cosine, -1 is the sine. So let's plug those in. We get -1 plus 1 equals 0. Is that true? Yes, it is, right? So what are only 2 solutions here? Very good. We're going to get rid of pi. So we get 2 solutions there. Again, fairly tedious, a little bit different from what we did yesterday. But once you see what to do, shouldn't be too bad. Shouldn't be, I mean, it's a lot of steps, but shouldn't be anything crazy difficult. Okay, so we're just going to finish with these 2. What's different about these? Okay, good, right? So there's something on the inside now, right? So let's take a look at what's there, right? So we see on the inside, there's a cosine. It's not just cosine of x or cosine of a variable. It's cosine of 3 times that variable. We're going to deal with that at the very end. What we're going to do first is the same thing that we've always been doing. We're going to try to get the cosine isolated and then find the values on our unit circle. We're going to deal with that 3t at the very end. All right? So let's just stick to what we've been doing, right? How can we isolate that cosine of 3t? Yeah, right, add 1 on both sides. So then we get 2 cosine of 3t equals 1. And then we can divide by 2. So then we get cosine of 3t equals 1/2. All right. It doesn't say it, but I'm going to write at the top, we're going to solve over the interval of 0 to 2 pi. All right, I'm not going to find infinitely many solutions. All right, let's just stick to that interval. Okay. Now let's check our unit circle. For what values does cosine equal 1/2? Not pi over 4. Pi over 3, right? So pi over 3, and then what's the other one? 5 pi over 3. All right, but is this equal to the inside t, or is it 3t? All right, we see a 3t in there. So this isn't our final answer. This is equal to whatever the answer is times 3. So 3t equals this, right? That's the only difference when there's something on the inside with the cosine or the sine, right? Once we get this far, how do we get the t by itself? divide by 3, right? Does that look pretty? Or are we going to leave it like that? No, what are we going to do? What would our final answer be? Good. So we can, over 1, keep, change, flip, right? 1 over 3. And so we get pi over 3 times 1/3, and that's going to get you pi over 9. So that's one of our answers. All right, let's try the same thing with the next one, right? 5 pi over 3 wasn't our answer. It's 3 times our answer, right? So let's divide everything by 3. Once again, write it over 1. You can keep, change, flip it. And then you get t equals 5 pi over 9. So then that's our other answer. All right, just an extra step in the beginning. I know a little bit more tedious than what we did yesterday, but again, once you see what to do, shouldn't be crazy difficult. Questions on that one? Maybe we need to see another, so that's fine. I'll try the next one. Again, the next one will also solve in the interval of 0 to 2 pi. What can we do there? Good, right? So let's add the square root of 3. And so we get 2 sine of 2t. So again, this one's like the last one in that there's something inside with the variable. All right, and then we can divide by 2. So then we get sine of 2t equals square root of 3 over 2. All right, so check your unit circle. Where does sine equal square root of 3 over 2? Okay, nice, pi over 3, and then where else? 2 pi over 3. Good, right? Is this our answer? No, it's 2 times our answer, right? So this is 2t equals this number. 2t equals this number. All right, so what do we have to do now? Yeah, right, divide our answer by 2. If it's easier for you to see it as you're multiplying by a half, maybe that's how you want to see it, that's also fine. However you think about it, that's perfectly fine. I know the way that this looks isn't the best, but as long as you know how to keep, change, flip, then it should be okay. What does this get you? Nice. Pi over 6, and then what does this one get you? Just pi over 3. All right, if you did 2 pi over 6, make sure that you're simplifying it fully. So we get pi over 6 as an answer, and then we get pi over 3. And those are our 2 answers. All right, good with that one? Hopefully a little bit more straightforward than the previous one. The previous page, I mean. That's about as complicated as it gets. This last page we're not going to do, just because, okay, it says it's not factorable. How you would do it is you would use the quadratic formula, you would get some weird radical answer, you would plug it into your calculator, and then you'd get a decimal. Your test is no calculator, and that honestly is just a pain. I hate this problem, so we're not going to do it. So that's it for this lesson. Tomorrow we'll review the day after, and the day after that I'm not going to be here, so you guys can just review in class. Your test is on Monday of next week. But by now you've learned everything, right? I'll hand your quizzes back tomorrow just so that you have it before the test. Right, if I'm not going to be here Thursday or Friday, then there's no way for you to get it if I don't hand it back tomorrow. So if you're making up, just keep that in mind, that if you're making the quiz up after today after school, you're probably not going to get it before the test. So just keep that in mind.